Hello and welcome to this module under course of microprocessors and microcontrollers. The course code is ELC104. Myself, I am Sunoj Raikar, Associate Professor at DMS College and Research Center, Asagaon, Goa. Name of this module is Architecture of 8051. What we are going to study in this is Harvard and von Neumann architecture, salient features of 8051 microcontroller, pin diagram of 8051 microcontroller, CPU registers, and architecture of 8051 microcontroller. After undergoing this particular module, student will be able to differentiate between Harvard and von Neumann architecture, describe salient features of 8051 microcontroller, describe the pin diagram and functions of various pins of 8051 microcontroller, explain the various CPU registers and architecture of 8051 microcontroller. Let us begin with von Neumann and Harvard architecture. Now, this particular one, first one is called as the von Neumann architecture and the second one is called as Harvard architecture. Von Neumann architecture is primarily used in microprocessor based architecture, whereas microcontrollers basically use Harvard architecture. It doesn't mean that microcontrollers are not available in von Neumann. There are some microcontrollers which are also available with von Neumann architecture. Example is MSP type of microcontrollers. In case of von Neumann architecture, as we can see, there is only one data bus and one address bus. And this data bus and address bus, which is connected to the memory, will be responsible for fetching the program memory as well as the data memory. And as a result, we know that once the instruction is being fetched, in order to complete the cycle, if the buses are busy with the instruction fetch cycle, then unless and until the instruction is completed, execution of the instruction is completed, the buses cannot be allotted for the data. Whereas here you can see that there is separate set of address bus and data bus for program memory and data memory. Now what is going to happen in this is that the instruction can be fetched by a separate set of address bus and data bus, and simultaneously the data also can be fetched by using separate set of address bus and data bus dedicated for data bus. Okay, so here what is going to happen is the time taken for the execution of a complete instruction in case of Harvard architecture is going to be less as compared to von Neumann architecture. Let us see some of the differences between Harvard architecture and von Neumann architecture. Von Neumann architecture, also known as Princeton's architecture, uses single memory space for both instruction and data, whereas Harvard architecture uses separate program memory and data memory. Von Neumann architecture, for von Neumann architecture, it is not possible to fetch the instruction code and the data simultaneously. Instruction code and data can be fetched simultaneously using Harvard architecture. Execution of instructions takes more machine cycles for von Neumann. Execution of instruction takes less machine cycles for Harvard. Von Neumann basically uses a CISC type of architecture, that is complex instruction set computing, whereas Harvard basically uses a RISC type of architecture, that is reduced instruction set computing. In case of von Neumann, instructions are prefetched instruction prefetching is a main feature, whereas instruction parallelism is a main feature in Harvard architecture. Also known as control flow or control driven computers, and Harvard is also known as data flow or data driven computers. Von Neumann simplifies the chip design because of the single memory space, and examples are 8085 microprocessor, 8086 or MC6800. The chip design is slightly complex in case of Harvard architecture type of processors due to separate memory space. Examples are general purpose microcontrollers. Even 8051 also is an example of Harvard architecture. Some of the salient features of 8051 are 8051 was introduced in the year 1981 by Intel. It has a 8-bit processor with Boolean processing capabilities. It has 4 kilobytes of on-chip program memory, which is also called as ROM, 128 bytes of on-chip data memory RAM, 68 kilobytes each program and external data address bus space, then two 16-bit timers, one UART, one serial port, full duplex UART, 4 I/O ports, each 8-bit wide. That means 32 bidirectional I/O lines are there. 6 interrupt sources, 2-level prioritized interrupt structure is implemented here. Then hardware multiplier and divide operations are available in case of 8051. 12 clock cycles per machine cycle is standard here. Then let's see the pin diagram of a generic 8051 microcontroller. Generic 8051 microcontroller is a 40-pin dual inline package type of a device. So there are basically 40 pins, and out of 40 pins, if you go to see, 4 ports are occupying 32 pins, then 2 supply and grounds are there. Then we have 2 pins for crystal oscillator, and then we have 2 pins meant for external access / VPP, and 1 pin for ELE, 1 pin for PSEN bar, that is program store enabled. So now let's see the functions of the various pins. First and foremost, let us see the ports, because ports are very important here. So there are altogether 4 ports. These ports are named as port 0, port 1, port 2 and port 3. Port 0 serves as an input-output port, and it also serves as a lower order address and data bus which are multiplexed using this port. So primarily the basic or the first function of port 0 is input-output port, and second function or secondary function of port 0 is that it can be used for lower order address bus and data bus. It's called as AD0 to AD7. So here it is written like that, AD0 to AD7. So port 0 is having 2 functions. One is input output, second one is address data bus, and this can be used, or this is used as address data bus when we are going for external memory or memory expansion. Next we have port 1. So port 1 is here, you can see this is port 1, and all the different pins of the ports are designated as 1.0, 1.1 and so on. Similarly 0.0 for port 0. So port 1 doesn't have any additional function. So it is having only one single function, that is primary function, and that is bidirectional input-output port. One more point to mention here that port 0 is having something called as very weak internal pull-ups. So if you want to use the port 0 pins for doing some input-output operations, then we have to connect something called as external pull-up resistors. Whereas port 1 is having good internal pull-ups. So similarly, port 2, here you can see port 2 is also having 2 functions. Primary function is simple input output, and secondary function is it's meant for higher order address bus. So port 2 also can be used for it can be also used for external memory interfacing. So whenever we find that the internal memory is less for our particular application, we can always go in for memory expansion by at the expense of port 0 and port 2. And of course we have to use these other signals also, like ALE and PSEN bar and all such things. Next comes port 3. So port 3, as we can see, it also has a primary function of simple input output, but at the same time each and every port pin of port 3 is having secondary functions. Okay, they are used for serving communication, like UART communication is done on port 3.0 and 3.1. Then 3.2 and 3.3 are used for external interrupt sources. Then 3.4 and 3.5 are used for counters and timers. Then 3.6 and 3.7 are used for external peripheral interfacing such as ADC, wherein we make use of write signal and read signal. And that's all about port 3 or port 3. So we have seen that each and every pin of port 3 can be used for serving different functions. At the same time, the primary function is simple input output. Then we'll see about this particular pin called as psen bar. So this is an output pin, and psen stands for program store enable. This pin is connected to OE pin of the external ROM chip. Okay, so there is a pin called as OE pin on the ROM chip. If we are going for memory expansion, then we have to connect this psen bar to OE. ALE is called as address latch enable, and it's also an output pin used for again whenever you are connecting the external memory, it is meant for demultiplexing the address and data bus, that is port 0, on which the AD will be floated on port 0, again for external RAM ROM. EA bar / VPP, this is called as external active low signal, external access. Pin is known as external access. This is an active low pin, is used to enable or disable the access of external memory. Finally, we have RST, which is called as a reset signal. It is an input pin and is a active high. And upon applying a high pulse at the reset pin, the microcontroller will get reset. That means the program counter is going to hold 0000. Some of the important registers of CPU registers of microcontroller 8051 are accumulator A. It's called as A. A stands for accumulator, and it saves the result of all the logical and arithmetic operations. B is another important register which is used in multiplication and division operation. So in case of multiplication, it saves the higher byte of the result, and in case of division, it saves the remainder. Then we have general purpose registers such as R0, R1, R2, R3, R4, R5, R6 and R7. So 8 general purpose registers are there. Actually, frankly speaking, there are something called as register banks, and each register bank is going to have these 8 registers inside. So altogether there will be 8 for the 32 general purpose registers for a microcontroller 8051. But they will be called as R0 to R7. Then we have DPTR, which is also called as data pointer. It's a 16-bit register primarily used for accessing memory, and can be used as 2 separate 8-bit registers like DPL and DPH. So we can actually break this down into 2 8-bit registers, and as and when required, we can use it as a 16-bit DPTR register or 2 separate 8-bit registers DPL and DPH. Then we have program counter, which is a 16-bit register, and it stores the address of the next instruction to be executed. So this is basically an architecture of 8051, which has been simplified as a block diagram here. This is same thing simplified in a block diagram, and you can see that it has a CPU, oscillator, interrupt controller, and then on-chip ROM, on-chip RAM, then timers, serial port, I/O port, bus controller, crystal oscillator is connected, I/O ports. There are altogether 4 ports, which are port P0 to P3, and each port is going to be having 8 bits. So 8 for the 32 bits are going to be there on I/O ports. And as we can see here, P0 and P1, they are also used for address and data in case if you are going for memory expansion. Serial port is going to have these 2 pins, TX and RX. So RX stands for receive pin and TX stands for transmit pin. Then we have seen that in the pin diagram we have seen T0 and T1. I'll just show you this T0 and T1, 3.4 and 3.5. So at that time I said it can be used for timers and counters. Okay, so basically counters can be implemented on 8051, and for counting the external events we make use of the T0 and T1. So these are these pins. Okay. Then external interrupts we have seen, pin 3.3 and 3.4. Sorry, 3.2 and 3.3, I suppose. Yeah, 3.2 and 3.3. These are external interrupts, so which are being shown here. And there is an interrupt controller over here. And all these, internal peripherals which are there of a microcontroller, they are connected by using these buses. So oscillator becomes one of the most important device, and because of the oscillator, it is like a heart of a microcontroller. It gives the timing signal for the microcontroller to run in synchronism. So the 8051 has an internal on-chip oscillator circuit which generates the clock pulses by which all internal operations are synchronized. The external resonant circuit is connected with the internal on-chip oscillator circuit to make the complete oscillator. Typically, 12 MHz crystal quartz is used, or 11.0592 MHz for better baud rate matching is being used. So ALU, that is your arithmetic logic unit, performs all the arithmetic operations such as addition, subtraction, multiplication and division, and logical operations such as and or not, XOR, and rotating operations. All these operations are performed on 8 bits of data because the microcontroller is 8 bits. Then memory, 8051 has separate on-chip program and data memory, and the amount and the type of on-chip memory is a key factor in differentiating all the members of the family. On-chip ROM on 8051 is 4 kilobytes, whereas on-chip RAM is 128 bytes. However, in advanced variants of 8051, the on-chip ROM and RAM can go up to 64 kilobytes and 256 bytes. Peripherals of 8051, it has two timers which are 16-bit, and there is another variation of 8051 called as 8052 which belongs to the same family, and 8052 has 3 timers. So these are used for timing and counting applications, and it also has a full duplex serial port UART, which is used for communicating with the other devices such as the PC. Okay, this is the reference which I used. Thank you.